started, are there any questions over the homework? You can grab a note sheet. Fine. No, you're good. Finally got them printed off. So with the sheet that y'all wrote on yesterday, you can copy them over if you want, or I do have a stapler up here. You can just staple them together. Either way works, because again, they're more for your benefit than they are for me. I am not collecting note sheets. I do not collect note sheets. Now the first thing we're starting off with today is this here, reflection across the x-axis and reflection across the y-axis. Now for us to reflect a function across the x-axis, we're going to use the general form negative f of x. If we're reflecting across the y-axis, it's going to be f of negative x. So if you want to circle or emphasize, because there's our two general forms. Across the x-axis is negative f of x. If we're reflecting across the y-axis, it's f of negative x. So just like we did yesterday with horizontal translations, moving it up, down, left, or right, where we stuck with those general forms, same thing with reflections. So when we look at this first one here, let f of x equal the absolute value of x plus 3 plus 1, write a function g whose graph is a reflection in the x-axis. So our general function would be g of x. So we have g of x in the general form for reflection in the x-axis is negative f of x. Where f of x is really just our function we're saying we're applying this to. Questions on this so far? Now at this point here, we can replace f of x, because it's still just f of x, with what it's equal to, which is our absolute value of x plus 3 plus 1. I can get it. Now looking at this one here, do we have something in front of the parentheses? We have that negative sign this time, yes? Unlike everything we did yesterday, there was nothing in front of that parentheses, nothing we had to do. But because we have this negative, it means we're going to have to multiply each term inside the parentheses with it. Now the absolute value of x plus 3 is a single term, a single expression. So we're going to multiply the negative by the absolute value. It's not going to multiply in, it's just going to stay out front. Same thing if we multiplied the absolute values by a number, it's going to chill out front. It's not going to actually multiply in. So negative 1 really is what we're doing. Negative 1 times our absolute value is just going to be negative absolute value. We also have to multiply it by the positive 1. Negative times a positive is a negative, telling us that we have negative absolute value of x plus 3 minus 1. Questions on this so far? And as we talked about yesterday, that negative 1 cannot go inside the absolute value. The positive 3 cannot leave the absolute value. So the reflection across the x-axis is going to be negative absolute value of x plus 3 minus 1. And that's it. Questions on this reflection? Let's look at the next one. Now, I'm going to rewrite the function. You do not have to. I would not rewrite it. I'm rewriting it here so I'm not scrolling up and down so we can see it all in one place. You have it easily visible right there on your page. Now for the next part, they want us to write a function h of x, whose graph is a reflection in the y-axis of the graph of f. And the general form for reflection in the y-axis is our f of negative x. Now, just like horizontal translation or left-right movement, if you notice, we don't have f of x anymore. We have f of negative x, which means every x in f of x is going to have to become negative x. So we still have the absolute value bar, but instead of x, we have negative x. We still have the plus 3, we still have the plus 1. Everything else stayed the same, we just switched the x to negative x. We put negative x in place of x. Is there anything in front of this x? Anything being multiplied by that negative x? Well, no, it's just negative x plus 3 plus 1. No like terms to combine. Simplified as it gets. That is a reflection in the y-axis. Questions on reflecting across the x-axis, reflecting across the y-axis. A little bit different than our horizontal up, down, left, right. Mainly in how we simplify stuff, but the main process is still the same, yes? Write a function h whose graph is a reflection in the x-axis of the graph. So we start off with the general form for reflection across the x-axis. It's our negative f of x. And just like with the previous one, we replace f of x with what it's equal to. We replace it with its function. The absolute value of x minus 5 minus 4. Then we just need to resolve this. We need to distribute this negative through. And when we multiply through, especially if we have absolute values, we're not going to multiply into the absolute values. So this is just going to be negative absolute value of x minus 5. But we wouldn't have minus 4 anymore. We would have plus, because the negative times our absolute value is going to make it negative. Negative times a negative makes a positive. Turn that absolute value negative, turn the 4 positive. Questions on this here? We feel pretty comfortable with this? Kind of, sort of. Let's look at one more. Write a function g whose graph is a reflection in the y-axis. So g of x is equal to f of negative x. General form, f of negative x. G of x equals f of negative x, because that's our reflection in the y-axis, the general form for it. And to apply it to this function, all we're going to do is replace every x in f of x with negative x, which gives us the absolute value of negative x minus 5 minus 4. Now the question is, why would I need the parentheses around the negative x? We would need it if there was, say, if it was 2x minus 5. If we had it this way, we'd have to multiply the 2 and the negative. If it had been negative x to start with, negative and negative would make a positive. We just put it there just to make sure there's no interaction. Questions on this here? I think we feel comfortable with reflections across x, reflections across y, yes? In that case, we're going to look at the last type of transformation we have. Horizontal stretch and shrink, and vertical stretch and shrink. Horizontal, vertical. Now, vertical stretch slash shrink is given to us in the form of a times f of x. That's it. It does not matter if it's a stretch. It does not matter if it's a shrink. A is the amount that we stretch or shrink the function by. So if it's a vertical stretch of 3, we're going to use a times f of x. If it's a vertical shrink of 3, or vertical shrink of 1/3, the general form is still a times f of x. Doesn't matter which we're doing. It is still that same general form. Horizontal stretch slash shrink is f of a x and flip a before plugging in. Because the graph of y equals f of ax is a horizontal stretch or shrink by a factor of 1 over a of the graph of f of x. So when we put it in, we've got to flip it. Opposite of what we think. Opposite of what we think. So they're going to give us a value. We've got to flip it, 1 over it, flip it, to get what it actually is, what we're actually plugging in. And really, that is the main thing. We got to just remember, hey, we flip it. If they give us 3, we have to plug it in as 1/3. If they give it to us as 2/3, we have to flip it to 3/2, 3 over 2. We have to flip that, whatever it is. And then it's going to work the exact same way. We use f of a times x. Let's actually see how these work. Let f of x equals x minus the absolute value of x minus 3 minus 5. And we're going to write a function h whose graph is a vertical stretch of the graph of x, f, by a factor of 2. Okay, we're doing vertical stretch first. Now, vertical stretch or vertical shrink, the general form is a times f of x. Yes? That's just the general form. It is vertical, yes? So what's A? A is 2. A is exactly what it is. Vertical stretch and shrink, vertical's nice. It's exactly what it is. A is 2. Now we still have f of x, yes? So we just leave it as is, at absolute value of x minus 3 minus 5. Replace a with its value of 2, replace x of x, f of x with what it's equal to. We get those here. Questions? Yes, kind of, sort of. We get it? Don't get it? Curious about the A, yes? Okay, yeah, because the A of f of x is the general form. A is telling us the amount that we stretch or shrink it by. Since it's a stretch of 2, A is 2. If it was a vertical shrink, let's say 1/2, A would be 1/2. So this is nice with stretch and shrink. There's not a different formula or different general form for the stretch or shrink vertically. It's A times f of x. Whatever A is the amount of stretch or shrink. If it's a shrink, we use A times f of x. If it's a vertical stretch, we use A times f of x. It's the same form for both. Any other questions? Now we just need to simplify this. We're going to multiply by each term. So the first term we have is this entire absolute value. We are not multiplying through absolute value. So it's just going to be 2 times the absolute value of x minus 3. Minus 2 times 5 is 10. That's as far as it goes. We can't combine like terms. There are no like terms. 2 times the absolute value of x minus 3 minus 10. Questions on the vertical stretch of 2. Let f of x equal the absolute value of x minus 3 minus 5. We want to write a function g whose graph is a horizontal shrink of f by a factor of 1/3. So we're writing g of x. What is the general form for horizontal stretch or shrink? It is our f of ax. Because that's the general form we have, f of ax, yes? And it told us that we are shrinking the graph by a factor of 1/3, yes? So A would be almost horizontal. This is, out of all of them, this is the trickiest one of the group. Because horizontal left, right, we just plugged it in exactly what it was. If it was left, we plugged in h as negative. If it was right, we plugged in h as positive, yes? Horizontal stretch and shrink, before you plug it in, flip it. Before you plug that value in, flip it. Put it as 1 over that amount. So if we flipped 1/3, the 3 is going to go to the top, 1 is going to go to the bottom. So the actual value of A is 3. If you're not sure, put 1 over that amount, 1 over 1/3. So the actual value of A is 3. That is the main thing with horizontal stretch and shrink. Flip A, flip the value they give you before you plug it in. Because when we talk about horizontal stretch and shrink, what we're saying is horizontal stretch says that it's increasing faster along the x-axis. Horizontal shrink means it's increasing slower. We're compressing it along the x. And to get that to actually apply, we have to have it as 1 over whatever the stretch or shrink is. Stretch is going to look like shrink. Shrink's going to look like stretch. Questions? Any other questions or any questions on that so far? Because once we do that, everything else falls in line like we've been doing. We don't have f of x anymore. We have f of 3x, which means all the x's in the function have to switch to 3x. So we have absolute value of 3x minus 3 minus 5. There's nothing in front of that parentheses with the 3x, so nothing to distribute through it, nothing to multiply it by. It just stays 3x. X minus 3 minus 5. As we can see, it does get narrower. Its horizontal stretch and shrink does weird things with this here. Questions on how we got this? Would we agree the big thing is just making sure to remember to flip it? Otherwise, it works the exact same as everything we've done. Let's do one more horizontal. Write a function g whose graph is horizontal stretch of the graph of f by a factor of 5. General form, f of a times x. Now, so a is told us to be 5, yes? Are we doing horizontal or vertical? Horizontal. Horizontal stretch or shrink, f of a times x is general form, and so we need to flip it. Almost, because what's the bottom? Bottom's always 1. So if we flip this, the 1's going to go to the top, 5's going to go to the bottom. Or you can do 1 over a instead of flipping. One over a is just 1 over whatever value they gave you. So the last one was 1/3. So if I do it here, 1 over 1/3, 3. Does that make sense? So we can flip it or put 1 over the amount given. Whichever one makes more sense to you. Okay? So the actual value of a is, this is the last time we will be applying horizontal translation or horizontal stretch and shrink. We will not talk about it the rest of the semester or the rest of the year. Because not so much that it's difficult, it's keeping track of this flip that gets everybody confused, and it's weird. Questions on how we got here? Since we don't have f of x anymore, we have f of 1/5 x. We've got to replace every x in the function with 1/5. Since there's nothing in front of the 1/5 x, we can just simplify the parentheses. We can drop them, telling us it's 1/5 x minus 1 plus the absolute value of 1/5 x minus 1 plus 2. Questions on any of this here so far? I think the big thing is just keeping the horizontal value straight, yes? Yeah. Horizontal is not what we're doing with this one. we want to write a function that is a vertical shrink by a factor of 0.25 of the function f. So general form for vertical stretch or shrink is a times f of x. Because that's just vertical shrink, yes? Vertical stretch and shrink, a is exactly what it looks like. We don't have to do anything to it. So for us here, our value of a is 0.25. And we can also replace f of x with what it's equal to as well. So we get the absolute value of x minus 1 plus 2. Questions on how we got here? Now we just need to distribute. So the first thing we're going to do is multiply the 0.25 by the absolute values, which is going to give us 0.25 times the absolute value of x minus 1. But we also have to multiply the 0.25 by the 2. 2 times 0.25, 0.5. That's it. Questions on this here? I think between the two of them, we feel very, yes. Yes. I think between the two of them, we feel very comfortable with, or feel decently comfortable with, vertical stretch and shrink. Yes? I'd say seeing one more horizontal might help. It'd be nice to see probably one more horizontal before we move on to the last piece. So this one here, so we skipped that one. Skipped one. I just didn't include it. So if you want to write this on that space, that's fine. We'll call it g of x. F of a times x. Yeah, so this one's not in the notes. So if you want to watch it, write it down in that blank space, the one we skipped. Yep. So you can mark 6 out and fill this in the gap. Because I will tell you this, on all of these note sheets, I do try to put more examples in than are needed sometimes. So g of x is equal to f of a times x, yes? So we're doing a horizontal stretch or shrink, yes? Now it told us that the amount we're stretching or shrinking it by is 2. But since we're talking about a horizontal stretch or shrink, we can't just plug 2 in. We've got to what? Flip it or put it in as 1 over a, where a is this given amount. So I can grab a calculator just to make sure. We go 1 over the a value, which is 2, which tells us it is 1 over 2. That's the value we need. Now, if you want, especially on your note sheet, or go back to that page and cross out, let's go back here, cross that out and say that the general form is f of bx. B is equal to 1 over a, and specify that, if that helps, keep track of that. That way we're knowing that the a, because it's one of the things I don't like as much. I think I'm going to do it that way the rest of the time, to where we don't get the value given as a and the value that we plug in as a. I don't like the repeated letter. You all right like that a little better to keep those separated? Horizontal stretch and shrink, the value they give us has to be 1 over it. And just like with all the ones we've done up to this point, we don't have f of x anymore. We have f of 1/2 x, which means every x in f of x has to be switched to 1/2 x. And as we've been doing, is there a number in front of these parentheses or sign? Yes. So we actually have to multiply these two together. I got it. So we're actually going to have to multiply the 4 and 1/2. And what is 4 times 1/2? What's half of 4? 2. So 4 times 1/2 x would be 2x plus 2. I can get those notes down for you. Any questions on this here? Last thing we're doing, combination of transformations. Now, combination of transformations, it seems like we're going to increase the difficulty. We're going to make this harder. We're going to introduce new things, yes? No. It is exactly what we're doing. We're just not stopping with one. Take it one piece at a time, as it's written. Let the graph of G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up. Now, for the most part, it's just going to be putting those in. But we're going to apply it to our f of x. So the first thing they listed was what? Vertical shrink by a factor of 0.25. For the middle one, we'll call this one h of x. H of x is equal to a times f of x. Because the general form for vertical stretch or shrink is a times f of x. For this here, what's our value of a? 0.25. So we plug that in for a, yes? We still have f of x, don't we? We can plug it in, and it's just, well, x. Questions on this? So at this point here, we need to simplify. We're going to multiply through. 0.25 times x is, well, 0.25x. Simplified as we get it. Simplified as it gets. And at this point, with all the ones we've done so far, that'd be it. We're done. We did it, yes? But what does it tell us? Followed by a translation 3 units up. Now, since this is the last transformation, I'm going to call it g of x. Again, as I said yesterday, the name really doesn't matter. It's just a way to name it. Translation up and down, vertical translation. The general form is f of x plus k, yes? Are we applying that vertical translation to f of x anymore? Well, no, we're applying it to 0.25x, yes? What did we name it? So really for us here, we're saying that h of x plus k is what we're doing next. We're starting to see f of x, h of x, it's just a name. f of x plus k is the general form when we apply it to f of x. Applying to h of x is just h of x plus k. What's our value k? 3, positive or negative? Luckily enough, we still just have h of x, so we can just replace it, yes? So it's just 0.25. Nothing to simplify, nothing to reduce. So we just drop those parentheses and call it good. So is this any different than what we've been doing? No, we just do multiple transformations on the function to get there. Questions on this here? We feel comfortable with these? Or would you like to see one more? Up to y'all. One more? I think we have 2 left or 1 left. Just 1? Yep. Let's go on and look at the last one. Because no matter how, even if they give something to us beyond absolute value of x, just x, that single term, we still do it the exact same way, one piece at a time. Let G be a translation 6 units down, followed by a reflection in the x-axis. We could start off with saying G of x. I am not going to be specific on how you name the final one. I'm looking more at the equation than the name. 6 units down. Vertical translation up and down would be f of x plus k. What is our value of k? It would be 6, because that's what it told us, and because it's going down, it would indeed be negative 6. F of x is, we still just have f of x, yes? So we replace it just with the absolute value of x. Nothing in front of the parentheses with our absolute value of x, so it's just going to stay the absolute value of x. Plus negative 6 is going to become minus 6. Followed by a reflection in the x-axis. What's the general form for reflection in the x-axis? Negative f of x. So, negative f of x, but we're going to apply it to g, so we'll say negative g of x. But again, the naming, again, as long as you are keeping it straight, that is more important. I am not counting off points, especially if you wrote h of x equals negative f of x. And then we take our next step. Here, even though that's g of x, not f of x, I am not taking a single point. It's just naming it. Then we need to do what? Multiply through by that negative, yes? So we multiply the negative by the absolute value, giving us negative absolute value of x. Our negative times negative 6 is going to make it plus 6. So our final equation, what it was asking for is negative absolute value of x plus 6. And no matter how many transformations we have, take them one at a time, and you will get to the answer. And that's it. 3 through 6, 11 through 14, 17 through 20, 27, 29. 3 through 6. Write a function whose graph g represents the indicated transformation of the graph of x. You don't have to use a graphing calculator to check it, so you're just applying the transformation. 11 through 14. Apply the transformation. 17 through 20. So 17 through 20, you're applying the horizontal, 2 vertical, 2 horizontal, so be careful with the horizontal. And then 27, 29, those two are asking you to do 2 transformations. One of them, 29, does have a horizontal stretch.